Hello. Today we're running an experiment to demonstrate Newton's second law. This experiment is to compare a computer model and a physical model of a constant velocity. Predicted position should be fairly close to a real model so long as all data is inputted correctly. My experiment has a small purple playpen ball passing from left to right in front of the camera. The calibration stick is set to the length of the ball, which is 0.0762 meters, and the origin is set at the center of the ball's initial position, with the positive x-axis to the right-hand side. Since the ball is moving to the right, it will have a positive velocity. As we can see, to the right we have our time, x, and y data. For this experiment, we can safely ignore the y-axis. To properly calculate our prediction, we must set some variables and use specific formulas. First, we set the ball's mass to 0.0101 kilograms. This is unfortunately not an exact number and is estimated based on total weight of a container of 250 identical balls. Next, we use the starting position of negative 0.001, 0, which we took from the video. We then calculate the starting velocity and come up with a vector of 1.3636, 0. This number is given by the formula velocity equals final position minus initial position over final time minus initial time, or delta position over delta time. We set delta t to 0.033 to match up with the camera's rate of 30 frames per second. We will run this model for no more than 0.867 seconds to match with the video. To attain constant velocity, we must set our net force to a vector of 0, 0. We update our velocity each iteration of the while loop with the following equation. Final velocity equals initial velocity plus the net force over mass times delta t. Since the net force is 0, the bulk of this equation can be negated, and the ball's final velocity will equal the initial velocity. Lastly, we update the ball's position with the formula final position equals initial position plus the ball velocity times delta t. When we execute this model, we will see that the ball will move from left to right and will move along the positive x-axis. Here we have our raw time and position data from our experiment and our model. The chart shows that the prediction and the model start off very closely. However, due to the ball's low mass in the experiment and friction with concrete as well as gravity and other forces, the ball's line begins to curve as the velocity drops quickly. Had this ball had more weight, the model and experiment would have been much closer for the entire length of the experiment. Had the axes been flipped, the model and experiment's data would have moved down in the graph along the negative x-axis instead of upwards in the positive x-axis direction. However, the deviation and prediction would still be accurate. I hope this video was informative, and thank you for watching.